Digital multimeter are measuring instruments that can measure quantities such as voltage, current, and resistance. Measure values are shown on a digital display, allowing them to be read easily and directly, even by first method of using a multimeter and its functions. Plug the base lead into the COM and V terminus. Always plug the black test lead into the terminal that is labeled COM for common. Always plug the red test lead into the terminal labeled V for voltage, since this is what you are testing. 2. Move the dial to the voltage setting for AC or DC voltage. Turn the dial to V tilde or the V with a wave sign next to it if you are measuring AC voltage. Switch the dial to VDC or the V with a horizontal line next to it to measure DC voltage. AC or alternate current voltage is used to measure things you might find around the house like wall sockets, microwaves, and other home electrical appliances. DC is mostly used to measure batteries. Set the voltage range to a higher voltage than what is expected. If you set the voltage range too low, you won't get an accurate reading. Look at the numbers on the dial and choose the setting that is closest to the expected voltage of what you are measuring while still being above that voltage. For example, if you are measuring a 12-volt battery and there are settings for 2 volts and 20 volts on your multimeter, set the dial to 20 volts. And if you don't know the voltage of what you are reading, just set the multimeter to its highest voltage rating. Number 4. Touch the probes to the both sides of a load or power source. Put the tip of the black probe on the negative lead and the battery or into the right side of a wall socket, for example. If you are sure which end is positive and which is negative, try putting the probe on each end and seeing what the multimeter says. And if it's showing negative number, you are positive, and negative, you are switched to another getting shock. Keep your fingers away from the tip of the probe when you are putting them near a wall socket. Keep the probes from coming into contact with one another, or you can generate a short circuit and possibly cause an electric fire. Always hold the probe by the collar handle, which are insulated to prevent shock. Number 5. Read the voltage on the multimeter screen. Once your probe are connected to the positive and the negative lead, you will get a reading on the multimeter telling you the voltage of what you are testing. Look at the digital screen to find the reading and take note of it if desired. Looking at your reading tells you whether or not the voltage you are measuring is average or not. For example, if you are measuring the wall socket and the multimeter read 100 volts, this is below the average of 120 volts, letting you know this wall socket voltage is low. If you are checking the voltage of a new 12-volt battery, the reading should be right around 12 volts. If it is lower or there is no reading at all, the battery is low or dead. Method 4. Testing currents. Plug in the test into the COM and MA or turn the dial to amps. Insert the black plug into the COM terminal. Put the red plug into amps or milliamps. Label with A or MA. depending on the amperage of what you are measuring. Locate the amp setting and turn the multimeter dial to it. Your multimeter likely has two terminal amps, one for current up to 100 amps and 10 amps, and the other measure up to roughly 300 milliamps. If you are not sure of the range of amperage you are measuring, place your red plug on the amps terminal. You can always switch to milliamps for a more precise reading if necessary. Some multimeters have two airs, one for alternate current used for residential power and represented by the wave sign, and one for direct current used in battery and wires and represented by a horizontal line with a dotted line underneath. Direct current is one that most used for this reading. 2. Break the circuit by disconnecting one of the wire in it. This allows you to use your multimeter as an ammeter to complete the circuit and measure the current. Unplug or otherwise remove a wire from the terminal it is connected to on side of the circuit, leaving the other wire connected to the terminal. It doesn't matter which side of the circuit you disconnect. The point is just to make a space to splice the multimeter into the circuit so it can act as an ammeter and tell you how much current is flowing through the circuit. Splicing the multimeter means that you are connecting the multimeter to the current going directly through the wires. Number 3. Touch the multimeter lead to free terminals and read the currents. Connect one probe to each of the terminal you just disconnected the wire from to splice it into the circuit. Read the screen to determine how much current is flowing through the circuit. It doesn't matter which probe you touch to which side of the circuit, your multimeter will give you a reading either way. You can troubleshoot electrical circuit by splicing your multimeter into different sections of them. If one section gives you a lower current reading, it might mean there is a bad wire that's inhibiting electrical flow. If you initially test amps and you get a really low reading, such as one, switch to testing milliamps to get a more precise reading. Measuring resistance. Insert the black test lead in COM and red test lead in ohms terminal. Stick the black test lead plug into the COM terminal. The red test lead plug goes into the terminal labeled ohms, which is the symbol for ohms. The unit that resists is measured in. The ohm sign is likely linked with the V sign, meaning the terminal to measure ohms and voltage is the same. Set the dial to a number on the multimeter's resistance scale. Look for the ohm symbol on your multimeter's dial area. Twist the dial to a number close to the expected resistance in this section. If you aren't sure what the expected resistance is, set it to a number at the top of the scale. You can adjust it as you measure until you get a precise reading. Resistance is the opposition to flow of current in an electrical circuit. We all know that. Conductive material like metal have low resistance, while non-conductive material like wood have high resistance. For example, if you are measuring the resistance of a wire, set the dial to just above 0. You can look up the expected resistance for different electrical components online or in an owner's manual. The ohms value on your multimeter can range from 200 to 2 million ohms depending on the specific type. Thanks for watching.